Hello, my name is Stefan. Welcome to our Nmap lecture. In this lecture, we will dive into the exciting world of network reconnaissance. So today we will explore a crucial task for penetration testers and system administrators, like finding online hosts. So we will discover how Nmap, the go-to tool for network scanning, offers enhanced host detection capabilities and provides valuable insights beyond the traditional ping utilities. Segment 1. The importance of host discovery. Before we begin our exploration of Nmap's capabilities, let's understand why finding online hosts is such a fundamental task. In today's interconnected world, where networks span vast geographic areas on the internet links countless devices, being able to identify active machines within a network or on the internet is crucial. Penetration testers rely on host discovery to identify potential entry points and vulnerabilities, while system administrators use it to monitor network health and ensure the smooth operation of their systems. Segment 2. The Nmap ping scan. So Nmap's ping scan feature takes host detection to the next level by sending a series of probes. So the Nmap goes beyond the ECMP echo request commonly used by traditional ping utilities like ping here. For example, ping, let's ping to ourselves here on our machine. And as you can see, this is just a ping, right? So Nmap goes beyond this echo request commonly used like this. So this comprehensive approach increases the accuracy and reliability of host detection, allowing us to gather valuable information about the online entities within a target network. So segment 3. We can execute a ping scan to launch a ping scan with an Nmap. So we will utilize this command here. So this code here. So Nmap SN, and here we will enter our target, right? So the SN here option instructs Nmap to disable port scanning and focus solely on the host discovery phase. It's worth noting that the Nmap supports a wide range of target specifications, including IP version 4, IP version 6, addresses, host names, and network ranges defined using the wildcards and CIDR notations. So for example, to scan the local network, we will first need to learn what is our local network IP starts with here, and now we will use this Nmap SN here 192.168.0.13.1 and 24 here. So, and as you can see, now we are scanning our host. So segment 4, analyzing the results. So once the ping scan is complete, Nmap provides us with a comprehensive list of hosts that responded to its probing packets. So these active machines represent the online entities within the target network segment or the internet. So by examining the results, we can gain insights into the network composition, identifying potential bottlenecks or misconfigurations, and further refine our understanding of the target environment. Segment 5. Uncovering additional details. Nmap's ping scans offer more than just a host discovery. So when executed with sufficient privileges on local Ethernet networks, Nmap can also identify MAC addresses and associated vendors based on MAC address identifiers. This additional information allows us to gain insight into the devices present on the network, aiding in network inventory management and security assessments. So in order to do that, we will just add sudo before Nmap to run it with sudo privileges, and here you will see also the MAC addresses right here. Segment 6. Under the hood. How Nmap works to understand the mechanics behind the Nmap's ping. This ping scans here. So let's delve into the inner workings of this powerful tool. This SN option, as mentioned earlier, disables port scanning and focuses solely on the host discovery phase. Depending on the user's privileges, Nmap utilizes various techniques to determine the online status of a host. So when executed as privileged users here, so Nmap employs a combination of techniques. So it sends TCP sync a packet to the port 443 and TCP acknowledge. So TCP ACK packet to the port 80 and ICMP echo and timestamp request. So this diverse probe helps to ensure that even hosts with restrictive fileware rules can be detected. So if the user running Nmap doesn't have the capability to send raw packets, it employs the connect system call to send the SYN packets on ports 80 and port 443. Segment 7. Exploring local Ethernet networks. When scanning local Ethernet networks as privileged users, Nmap activates ARP neighbor discovery, so further enhancing host detection capabilities. So by leveraging ARP request, Nmap can identify MAC addresses and associated vendors, and this information becomes invaluable in understanding the composition of the network and identifying the types of devices connected. So in conclusion, Nmap revolutionizes the way we discover online hosts with its robust ping scan capabilities. And by leveraging Nmap's extensive probing techniques and privileged user functionalities, penetration testers and system administrators can gain a comprehensive understanding of their networks. Remember, host discovery is the first step towards a secure and efficient system. So go ahead, unleash the power of Nmap and embark your network reconnaissance journey. Hello, my name is Tayfun, and in this lecture we will explore the fascinating world of a network reconnaissance. So Nmap is renowned for its extensive range of host and port discovery techniques, allowing penetration testers and system administrators to gather critical information about their networks. By utilizing these techniques, we can effectively scan hosts even in the most restricted environments. So let's explore some of the key techniques employed by Nmap for host discovery. We can also trace routes with Nmap. So tracing routes with Nmap from the scanning machine to the target host can provide valuable insight into the network topology. Nmap enables us to include trace route information during our scans. So for example, now we will enter the Nmap SN, Nmap SN. We will add the trace route option. So by using this option, we can trace the path taken by packets from our machine to the target host. Let's do this example here. So Nmap trace route, and here we will enter some website. In this case, it's going to be, for example, CodeSelly. This is our application, our website, which we installed for penetration testing in this course here. And as you can see here, trace route has to be run as a root, and we will use this sudo here. And after that, and as you can see here, this is our trace route. So this command initiates a ping scan with a trace route enabled for both the CodeSelly and our host machine. So we can also add another here, for example, google.com, and here that's it. So we are allowing us to visualize the network path and identify potential bottlenecks or routing issues here. As you can see, we don't have any issue on routing here. So segment 3, leveraging NSA scripts during host discovery. Nmap's scripting capabilities through the Nmap scripting engine NSE here provide a powerful way to gather additional information about a target during the host discovery phase. By executing the Nmap scripting engine scripts, we can extract valuable insights about the target's services, vulnerabilities, or even perform specific tasks. To execute Nmap scripting engine script without conducting a port scanning, we can use the SN option to skip port scanning and specify the desired script using the script option. So here what we're gonna do is nmap script here, and we will use the DNS root as a nmap scripting engine. So DNS root here, and after that we will enter our target domain or IP address. So in this case it's going to be codesally here.com, and here we will wait the execution here. Let's actually run with the sudo privileges. And here, as you can see here, we got no target specified, and so 0 host scanned. And here, if you are getting this error, you can also use the alternative script for this here. So instead of writing DNS root here, you can also write the DNS nsec here and enum, and after that you enter your domain or IP address. So here, this is an alternative, and this script performs a DNS enumeration by querying for NSEC records, which can provide valuable information about the domain. And here now we will get an output here. And also keep in mind that the success of this command depends on the availability of this DNS nsec enum script on your network configuration, and you may need to install additional Nmap scripting engine scripts or adjust the command according to your specific environment. So if you need any assistance, if you encounter any errors, feel free to ask me on the question sections of our course. And as you can see here, we got a lot of information here. We got ports and this here. So here in this command, we are executing this DNS nsec enum script during host discovery, which attempts to brute force DNS records for the codesally.com domain. This can reveal hidden subdomains, but also provide valuable information here, and as you can see, open ports and so on. So we can also use the SN here before the script here, and let's see how the port will change. And as you can see here, this is now we are not scanning port, since this parameter will not scan port here. And here we are sending this host record server here, and as you can see here, our hosting for this domain contains this domain address here, and this is the IP address of this. And one interesting Nmap scripting engine script available in Nmap is broadcast ping script, which utilizes a broadcast ping request to identify online host within a network. By broadcasting a ping message, Nmap can detect hosts that respond even if they have a restrictive firewall rules. And to use this script, we specify it with this script option as we did earlier, along with the desired target range. So we will do nmap sn here, script again with q here, script, and after that we will enter the broadcast ping and 192.168. Let's actually see our if config IP local IP address 13.138 13.1 here, and after that we will enter the 24, and here nmap sn. So we need to, let's actually, oops, we had the error with this typo here, broadcast, and that's it. And as you can see, it's not running for lack of privileges, so we need to run it with sudo here, root privileges here, and now you will see an output. And here, so with this command, we are scanning the local network with the IP range of this 1/24, which we will scan this IP address from 0 to 256 here using this broadcast ping. And here, this can be particularly useful in scenarios where a host might not respond to traditional ping requests here. So in conclusion, Nmap discovery capabilities provide a powerful arsenal for network reconnaissance by understanding the leverage techniques such as traceroute, NSA, Nmap scripting, engine scripting, and specialized scripts like broadcast ping. We can gain comprehensive insights into network environments, identify active hosts, and uncover potential vulnerabilities. So equip yourself with the knowledge of Nmap's host discovery features and embark on your network reconnaissance journey with confidence. Hello, my name is Stefan, and in this lecture you will learn how to discover open ports with Nmap. In the realm of network reconnaissance, one of the most valuable tasks is to determine the port states of a target. This process is commonly known as port scanning. So Nmap, the versatile network scanning tool, excels at this task. So providing valuable insights into the running services on a target. So in this segment, we will explore essential Nmap options related to port scanning and learn how to effectively list open ports on a target. Segment 1. Launching the default scan. To initiate a default scan with Nmap, all you need to is the target information, which can be an IP address, host name, or even a network range. So let's take a look at this example here. So nmap codesally.com. So here, this command will initiate a scan on the target host codesally.com and provide detailed information about the open ports and their corresponding services. And here it is, the output here. And as you can see, not shown 988 filtered TCP ports and so on. So you will also learn what is here. So in segment 2, so you will understand the scan results here. So the scan results generated by Nmap offer a crucial information about the target host. Let me actually open the Gromit here, and I will draw things on the screen to explain this better. So here we have, alongside with the IPv4 and IPv6 addresses, reverse DNS names, and latency details. The results highlight the ports and their respective states, and the port states are categorized like this here. So in the first here we have open ports. This here in open here, as you can see, all of these ports are open here. So with this we are indicating, so Nmap indicates that the service is actively listening for connections on the port open here. And also we have the closed. With this here, Nmap indicates to us that the probes were received, but no service was detected on the port. And we also have the filtered. So this indicates that the probe's reception couldn't be determined, possibly due to the filtering mechanisms. And we also have unfiltered. So with this here, Nmap indicates us that the probes were received, but the state couldn't be established. And we also have open filtered here. This means that indicates that the port appears to be either open or filtered, but the state couldn't be determined. And we also have the closed filtered here, which indicates that the port appears to be either closed or filtered, but the state couldn't be determined. And here we will also learn how to customize Nmap scans. So while the default scan provides valuable information, Nmap offers a plethora of customization options. So for instance, you can specify alternative DNS server using the DNS servers option like this, DNS servers option to control DNS resolution during the scan. For example, this Nmap DNS servers here, and we will enter the Google DNS here, 1888 here, and after that comma we will type, and 8.8.9 4.4 here, and now we will do codesally.com. So by providing this DNS server, Nmap will utilize these servers for hostname resolution. And here furthermore, Nmap performs host discovery to determine if the target is online before conducting port scanning, and you can skip the host discovery step using the PN option here. After Nmap PN, uppercase P and the lowercase n here, and here you will see another result. It might take here, actually let me use the sudo here, sudo enter password, that's it. And here this command will directly initiate port scanning without prior host discovery with uppercase P and lowercase n options here. And here Nmap employs various scan techniques depending on the user's privileges, and the default scan can utilize a synchronized SEN stealth scan or TCP connect scan here. So these techniques ensure comprehensive port scanning while considering the user's privileges and network environment. So port scanning with Nmap unravels the network services running on a target, enabling us to gain insights into potential vulnerabilities and secure our networks. By understanding the scan results customizing the Nmap scans and being aware of the underlying scan techniques, we can effectively explore open ports and their associated services here. And as you can see, we are seeing services FTP, SMTP, RSFTP, domain, HTTP, POP3, Nmap, and so on. So equip yourself with Nmap's port scanning progress and unlock the secrets hidden within your network. Welcome back, fellow network explorers. My name is Tayfun, and in this lecture we will delve into the fascinating world of Nmap port scanning. We will delve into advanced techniques that will help you uncover valuable information about target systems and services. So grab your virtual magnifying glass as we embark on this Nmap journey together. So Nmap offers a variety of port scanning techniques that cater to different scenarios. Understanding these techniques will empower you to choose the most appropriate method for your scanning needs. So by default, the privileged users enjoy the benefits of a SEN stealth attack, synchronizing stealth attack. So this technique utilizes raw packets to detect port states using a technique known as half open. So on the other hand, unprivileged users who lack the ability to create any raw packets rely on the TCP scan technique. So TCP connect scan technique actually. So this method completes each TCP connection fully, making it slower compared to SEN synchronizing stealth scans. So fine-tuning our Nmap scans to focus on specific port ranges is a valuable skill. It allows us to narrow down our search and optimize performance, especially when dealing with multiple targets. So you can specify port ranges in various ways using Nmap P option here. So for example, you can use comma separated lists to scan multiple ports like 80 and 443. Like this here, Nmap P here, and 80 443, and here we will enter the codesily.com, and here we are now scanning only port 80 and port 443, and as you can see here they are open. That service port 80 uses on the service called HTTP, And here for port 443 uses HTTPS, and they both open. Alternatively, you can define range using hyphens here. So for example, such as you can write like P here, and 1 to 100. And here we are telling Nmap to scan ports from 1 to 100 on codesolid.com, and as you can see here, Nmap showed us the open ports on the specific domain address. Nmap also provides the flexibility to target specific ports by protocol. For instance, you can scan TCP port 25 and UDP port 53 on a target using this command here, again P here, and without space after P we enter the T here 25 and U here 53, and here you will enter the target domain or IP address. In this case it's domain here, codesolid.com, and here let's press enter. And as you can see here, your port specifications are illegal example of proper port here. So we did something wrong here, and here after that, oh sorry, we need to add 2 dots here. Yes, that's it. And here your ports include U, but you don't have specified UDP scan with SU here. So you can also scan with this, but in this case we just scan the TCP here and here. And as you can see, it's filtered and it's a SMTP here. SMTP service is actually used for emails and email communication. So here, additionally, you can focus on ports associated with specific services using service names such as Nmap P here, and after P, let me clear that. So Nmap P here, Nmap P, and after P you can enter with space here. So Nmap P SMTP here, and you will enter domain name or IP address here, codesolid.com. And now we have a segmentation fault here. Let's actually use with sudo here, enter password, and as you can see here we got segmentation fault again. This fault is actually a bug on the Nmap's this version here, so I think they will fix that in next versions. But here you can also fix that by uninstalling the purging and then installing Nmap again, which we will do in next lectures, how to fix that fault here. So here now Nmap here also provides the flexibility to use the active network interface in order to, however, there may be instances when it fails to do so, or when you need to select a specific interface for network testing purposes. So to ensure Nmap scans using the desired network interface, for example, let's see what is our network interface. In this case, it's the ETH0. So here, to ensure Nmap scans using the desired network interface, you can use the E argument followed by the interface name. For example, in order to do that, you will enter the Nmap here, E here, argument, and after that you will enter the ETH0 in my case, and here, and after that you will enter the code target name, and here in this case our Nmap, this code here forces Nmap to use the ETH0 for the scan. And here, as you can see here, you can, oh sorry, so you can also use the press T to debugging, or you can use the arrow case to show the process here. And here, as you can see here, it's still using that. So it might take some time here. I know it's actually halfway down here, etc. 59% here. And here our scan is complete with this preferred interface here. So, and as you can see here, we ensure that we are now using the ETH0 for Nmap interface for the scannings here. And congratulations, you learned some advanced techniques for port scanning with Nmap by understanding the differences between privileged and unprivileged scans, and scanning specific port ranges and selecting the ideal network interface at the end, and you are now equipped to conduct precise and efficient network reconnaissance. So remember, responsible scanning is essential. Always ensure you have a proper authorizations and adhere to ethical guidelines when performing security assessments. And so go forth, explore the depths of your network and uncover the hidden treasures that await with Nmap. And I'm waiting you in the next lecture. Welcome back, security enthusiasts. In this lecture, we will explore the powerful target specification options provided by Nmap. Understanding different target formats and scanning techniques will enable you to effectively scan IP addresses and host ranges. So let's dive into the world of Nmap target specification. First thing we're going to learn is multiple host specification. The simplest way to specify a target is by directly listing the IP addresses or hosts you want to scan. You can specify multiple hosts by separating them with spaces. For example, nmap let's codesally.com, and after that you can also enter the local IP address. Let me actually look at my local IP address. Ipconfig here, ipconfig, and here 13.138, 13.138, and so on. So here, this command will scan the IP addresses of Codesally or domain here, and this local IP address here. And here, we can also have octet range addressing and wildcards. So to simplify the specifying a range of hosts, you can use octet range addressing. It allows you to specify a range of IP addresses by using a hyphen between the starting and ending addresses. For instance, to scan host of, for example, this here, let's actually delete the domain for now. We will use on the local host of this here. So to scan the host of this here, 192.168.13.1 and 192.168.13.3 here, and as you can see, we will scan this, right? So you can, instead of this, you can use, for example, this IP address here, the only this IP address, and after that you will enter the 168.13.1 here, and after that ternary operator here, the minus operator, and here you will enter the IP address you want to range from. So if you want to scan the IP addresses from 1 to 20, you can use this like this here. And now in this case, octet range intuition also support wildcards. Keep in mind, enabling you to scan from 0 to 255 with the expression like this here. And here, this is especially useful when you want to scan a subnet with large number of hosts. And you can also exclude hosts from the scan here. Let's actually clear that. So sometimes you might need to exclude specific hosts from your scan, and Nmap provides the exclude option for this purpose. It allows you to exclude one or more hosts from the range being scanned. So here's an example here. Nmap 192.168.1.1 to 255 here, and we will use the exclude here with 2 minus operator, exclude, and 192.168.1 point, for example, or oops, actually our IP address is 13 and not 1, 13 sorry, here 13 point, for example, let's exclude 13.3, right? And here with this command we are excluding the 13.3 from the range of this host being scanned. Alternatively, you can create an exclusion list in a file using the exclude file option to simply list the IP addresses or host you want to exclude in the file, each separated by a new line. For example, let's actually create a new file in graphical user interface here, create document and my exclude list.txt here, and after that you will open that. So of course we need to use it some notepad here. Ouch. Or mousepad, I think. Here, mousepad. This is a text weaving program in Kali Linux. Here. So now what we are going to do is we will write the IP addresses we want to exclude here. And here, so we will save this, and after that what we are going to do is nmap exclude file here, and after that you will enter the file path. You can also enter the file path using this home here, Kali, and exclude list.txt, and after that you will enter your IP address range you want to scan, in this case from 1 to 255. Oh, sorry. Exclude file, unrecognized option, exclude file here. Let's actually try it without this here, and exclude file again, error here. So if you're getting this error, you're probably using the newer versions of this Nmap here. So in order to fix that, we will use some grep and here. So however, you can achieve a similar result by using a combination of other tools and commands. And as I said, one approach is to use grep command to filter out the IP addresses or host you want to exclude, and then pass the filtered list to Nmap. So let's actually clear here. So we will firstly, as you remember, we have created the file exclude list.txt. So let's actually read it. Cat exclude list.txt, and here this is our excluded, this is the IP address that we want to exclude from our scan, and we will using the grep command to exclude the IP addresses or host from the list you want to scan. So you can use the v here. Let me actually do it again. Nmap v option to invert the match and select non-matching lines. So here nmap f here, and here we will exclude list.txt, and here we have all hosts.txt, and after that we will enter the filtered.txt here, and previous, sorry, here we will use the sudo again. If you are getting this kind of errors, probably the sudo will fix it. No targets were specified, and here fail to resolve exclude list.txt and all hosts.txt here. And here we need to create the all hosts.txt in this case, and in order to do that we will use the sec here f192 here with the quote here 192.168.8.13.g here, and we will unquote it. So from 1 to 255 here we will use this pipe aw key here, and here we will print it one by one, print 0 here, and after that we will uncode it and we will write it to all hosts.txt here. And now let's cat the all hosts.txt to see what's inside. And as you can see here, this is all the hosts from 1 to 255. So what we're going to do is we will run this command again, nmap command, and as you can see we got the error again, all hosts.txt, when no targets were specified. And here, so here we have the two files, all hosts.txt and exclude list, and we have the filter.txt here, and here this is our output. So here we also have the exclude list.txt and all hosts.txt. And here, sorry for the confusion here, instead of using nmap we need to use the grep here. So what we're going to do is we will change the nmap to grep here, grep, and here that's it. And now let's open the filter.txt. Actually we can use the we can open the filter.txt with cat here, and as you can see here we have excluded the IP addresses from our list, and 20, 21, 22 and 23 it doesn't exist because it already existed in filter. So this is a filtered list that all the ports that we want to scan. So we have subtracted exclude list from all hosts here. So let's actually watch the exclude list here, and as you can see we don't have the 23 here, 22 here, and we will also don't have the 112 here, and as you can see here we don't also have the 112 here, and so on. So what we're gonna do is here, and now we will use the nmap to scan all of this. Nmap lowercase e here and uppercase L here, and we will pass the filtered list to nmap for scanning, and we will enter the filter.txt, and here nmap scans that. And keep in mind that this method assumes you have a list of all the IP addresses or hosts you want to scan initially, and a separate list of IP addresses or hosts you want to exclude. Adjust the commands accordingly to suit your specific requirements, and please keep in mind that the availability of certain features or options in software tools may be changed since the 2023. So this is the last version and updated version of this course, and it's always good idea to you can also watch the documentation and official sources to make this nmap to more usable, and keep an eye onto the updates. And we can also use this CEDR notation for targets. So CEDR notation, and as actually this CEDR here also pronounced as the CIDR. So this notation provides a compact method for specifying IP addresses and their routing suffixes. It also it allows for more granular subnet masks compared to classful addressing. And CIDR notation consists of an IP address followed by a / and a network prefix length. The network prefix length represents the number of network bits, and for example in CIDR notation, actually let me open the grommet here to write marker here. So here the CIDR notation 24 after the IP address, this means the subnet mask of 255.0, indicating that the first 24 bits of the IP address are the network portion, and the remaining 8 bits are for host addresses. So to scan the 256 hosts in this range, from for example 0 to 255, you can use the CIDR notation after the IP address 24 here, right? So in order to do that, we will do some example here. So nmap 192.168.13.0, and we will use the CIDR notation of 24, and as you can see here we will simplify scanning an entire subnet. So we can also work with a targets list in nmap here. For example, let's actually create a new target list here. Let's open the create document here and target my target here .txt here, and here we will open with it with the mousepad here, and now we will enter some IP addresses. In this case 192.168.113.138, 2.168.13.2, and so on. So we in this case we will have two addresses for the scan, and in order to do that, let's actually use the cat targets here, my targets.txt, and as you can see we have two targets. And in order to scan all of the IP addresses in this list, we can use and also to load the targets from the load the targets from the my targets.txt file. You can use the nmap as we did in previous lecture, previous example, lowercase e, uppercase L here, and my target.txt here. And this feature greatly simplifies scanning multiple hosts. And in the target file, you can also mix different target formats. For instance, you can also add here, let's actually open the file here. So 192.168.13.20 to 50, right? So with this, you can also mix different IP addresses and IP ranges in the same file. Remember, here you can add comments to your target list by starting a new line here with this character here. This is really dangerous IP here, and this allows you to annotate and organize your target files for better clarity. And fantastic, you learned the various target specification techniques in Nmap, and whether you need to scan specific hosts, define IP ranges, utilize CIDR notation, or work with a target list. Nmap offers a versatile set of options to meet your scanning requirements. And I'm waiting you in next lecture and here. Hello, my name is Tayfun. Welcome to another awesome lecture of Nmap. Nmap is a versatile network scanning tool. It's widely recognized for its exceptional capability to not only detect the open ports, but also identify the operating systems and services running on remote hosts. So this recipe explores the process of fingerprinting operating systems and services using Nmap, providing valuable insights for security assessments, vulnerability detection, and network monitoring. Service detection is a crucial feature of Nmap that unveils detailed information about the specific software versions running on a target host. To enable service detection, you can include the SV option in your port scan command. For example, nmap sv, and here you can enter the target host here. In this case, let's actually scan the codesily.com, and here by employing this sv option, Nmap initiates service detection and augments the scan results with an additional column named version, displaying the precise software version associated with each detected service. And here now we are waiting for, let's actually, and as you can see, you can, by using the arrow here, arrow keys, you can see the process here. And here let's actually learn my so open my Windows machine on my I open my Windows machine on my virtual machine here. Now what we're gonna do is scan all the hosts to find that open here fastly, and here we'll also see that, and our scan is almost complete. It's 81% here. And here our operating system detection is ended here, on codesally.com, and here, as you can see here, we are seeing the domain here with ports and so on. We have next service fingerprint. So when performing a port scan with a service detection enabled, Nmap furnishes an extensive report on the identified services. So the service version information is enclosed in parentheses here, Red Hat Enterprise Linux 6. So let's consider an example where we scan well-known scan me nmap.org host here, and as you can let's actually read this, and here we are seeing some information here, fingerprint, open ports and their versions, their services, light speed, so on. So this gives us a good insight on what this hosting is using. In this case, for example, SMTPD 4.95. In this case, we can search exploits for this. We can also search exploits for this. In this case, it's a Red Hat, but in most cases, it's actually pretty secure, but nothing is unhackable. So, and here we have SMTPD as well. So here, let's actually use the Nmap scan me here. Let's clear, and now Nmap SV again. Actually, if we use the sudo, it will be pretty good here. Nmap scan me.nmap.org here, and oops, Nmap SV sudo. We forgot to write Nmap here. Nmap SV scan me.org, and here, here we will see an output here, which the output showcases a comprehensive list of open ports along with their corresponding services and versions, aiding in identifying potential vulnerabilities and monitoring software updates. So here we are waiting for this. It's actually, and here as you can see, 16% is done by now. Let's check it again. As you can see, it's 18.13 here. So while scanning, let's actually use another here. So we can also enable the operating system detection here. So in addition to service detection, Nmap offers powerful operating system detection capabilities. To activate operating system detection, you can include the uppercase O option in your scan command, and keep in mind that running Nmap with operating system detection requires privileged user access. In this case, we will use the sudo here again, and sudo nmap here, and uppercase O, and here we will write codesally.com and enter Kali here. That's it. And here our scanning is complete by now. You can see the server again, the services, and here we are, Nmap provides a output here. All scan results may be unreliable because we could not find at least one open and one closed port. And here aggressive operating system guesses is action tag this here, probably servers, and it's probably Windows in 97%, Linux 94%, and VMware Player Virtual NAT device, and here, so no exact operating system matches for host. So here we can also scan our local host. So I have Windows 10 machine on my network 133 here, and now we are going to scan this. So because of our Windows system, so our target system in our local host, it will do much more fast. And here, as you can see here, it's guessing Microsoft Windows 2019, which is Microsoft Windows 10. And here aggressive OS guesses is say they are the pretty same here, but that's it. So this is how operating system guessing works. So let's actually I want to also tell you something. Let's actually run it again. So this upon enabling the operating system detection, Nmap appends operating system related information at the bottom of the port list in the scan result, as you can see here. And here Nmap service detection is facilitated by the SV option, operates by dispatching a series of predefined probes for the Nmap service probes file to the open ports detected during the scan. So these probes are selected based on their likelihood of identifying a specific service, taking into account the port number and rarity score. So service detection plays a critical role in various scenarios, such as vulnerability assessment, service verification, and patch update assessment. So similarly, the -O option here empowers Nmap's operating system detection features. So it achieves this by sending probes to the TCP, IDP, and ICMP protocols against both open and closed ports. So Nmap's vibrant user community has contributed an extensive collection of fingerprints encompassing diverse systems, including residential routers, operating systems, IP webcams, and various hardware devices. And it's important to note that operating system detection necessitates raw packet manipulation, requiring Nmap to be executed in privileged mode. So Nmap adopts the common platform enumeration (CPE) naming scheme, so widely embraced in the information security industry to accurately identify services and operating systems. So this standardized convention facilitates precise identification of packages, platforms, and systems, streamlining vulnerability assessment and risk analysis. Hello, my name is Stefan, and in this lecture we will learn how to scan random targets on the internet. Nmap, a powerful network scanning tool, offers a fascinating feature that allows researchers to conduct scans against random targets on the internet. Although it's important to note that aggressive scanning without permission is not recommended and may be illegal in certain countries, and generating a sample of random hosts can be valuable for research purposes related to publicly accessible hosts. So let's explore how to generate random hosts as targets for Nmap scans. So to generate a list of n random target hosts, you can use this nmap command. Nmap lowercase e uppercase r here, so we will do 20 here. And now here we are generating 20 random hosts. So here let's actually wait, and here as you can see here, we scanned randomly and there is 0 hosts up. So now let's delve into the prevalence of ICMP, Internet Control Message Protocol, on remote servers, and we will launch a host discovery scan against 3 random targets. So nmap sn, so this is a host discovery, and lowercase e uppercase r, and we will do 3 here. And here the scan results will display information about a scanned host. In this case there is a 0 hosts up, so let's actually make it 50, so we will have more chance to get the online hosts here. And here you can use the arrow keys to see the percentage of the process, and here it's 9400. And as you can see here, there's a 3 hosts up, and here accumulatortechnologies.com and so on. So the scan results will display information about a scanned host, such as their IP addresses, responsiveness, their domain if they have any, and the latency. And this is the sample output that Nmap will give it to you. And let's actually learn how it works here, right? So by using the Nmap lowercase e and uppercase r option followed by some number here, Nmap generates a specified number of external IP addresses and utilizes them as targets in the scan. So this target assignment can be combined with any other scan options as needed. So while this feature can be valuable for internet research, caution should be exercised when using it, and Nmap has no control over the external IP addresses it generates, meaning that the generated list may include critical machines under heavy surveillance, so keep in mind. To avoid any unintended consequences, it's important to use this feature responsibly and ethically. And there's also more here. So if you want to generate an unlimited number of IP addresses and run the scan indefinitely, you can use Nmap lowercase e, uppercase r here, and 0 option. For example, if you're interested here, in this case, oh sorry, no, it's not 0. So 0 option, and here we will scan it indefinitely until the IP addresses end, or we have some error from program, right? And here, for example, if you are interested in finding random online NFS, here network file system shares, you could good this command here, nmap. First we will enter the port here, so because NFS network file system uses 2049 port, 2049 port, and here we will use open and IR here. So here we will scan open the online machines that uses this port, and this port is open in that machine here, so we will scan it on unlimited here. And here, as you can see here, we have a here, as you can see here, it's running all the way. So here, and there is also legal uses with port scanning here, so it's essential to be aware of the legal implications surrounding port scanning. Engaging in port scanning without proper authorization is generally unwelcome and even illegal in certain jurisdictions. And before conducting any scanning activities, it's crucial to research and understand the laws and regulations in your local jurisdiction. So Nmap provides comprehensive documentation on the legal uses associated with port scanning, which can be found on their websites here. Let's actually go there. So we will go nmap.org here, book and legal issues.html. So here I highly recommend that anyone considering internet-wide scanning takes the time to read and understand these resources. Here there's also, as you can see here, security list, security tools here, so there might be some error legal uses here, so they might be changed this link here. So but here you can see, we also can Google it here. We can also go it here, and here Nmap legal uses, and here we will go to Nmap's official website here, and that's it. So yes, we need to use this here. So that's it. And as you can see here, when used properly, Nmap helps protect your network from invaders, but when you use improperly, Nmap can, in rare cases of course, get you sued, fired, expelled, jailed, or banned by your internet service providers. So reduce your risk by reading this legal guide before launching Nmap here. So there's a here, as you can see, there's a port scanning is not crime, and the strong opinions on a port scanning legality and morality. And here, as you can see here, I love BMW, their nice car here, M3 I think, yes. And here you can read all of this chapter to understand the legal uses that comes with scanning ports here. So I'm waiting you in next lecture.